An insurance policy pays a benefit of 4,000 if an electrical device fails during the first year. The amount of the benefit decreases by 1,000 each successive year until it reaches zero. If the device has not failed by the beginning of any given year, the probability of failure during that year is 0.4. Calculate the expected benefit. Now, it can fail in years 1, 2, 3, 4, with payments being 4,000 for the start. Yeah, 4,000 for the start, and then it decreases by 1,000. So 3,000 in the second year, 2,000 in the third, 1,000 in the fourth, and in the next year it will be zero. So we don't need to list that. And the tricky part is the probability of failure during a year. So now, remember, if at the beginning of any given year it hasn't failed yet, then the probability of failing during that year is 0.4, which means that if it hasn't failed at the beginning of any year, then the probability of not failing in that year would be 1 minus 0.4, which is 0.6. So failing in the first year is simple, that's 0.4. But the failure in the second year will happen if it has not failed in the first year, which will be 0.6, and failed in the second year, which would be 0.4, and means multiplication, so the result is 0.24. Similarly, not failing in the third year will happen if it has, failing in the third year will happen if it has not failed in the first year, 0.6, and not failed in the second year, 0.6, and failed in the third year, 0.4. And so the same for the fourth year, that it has not failed in the first, second, and third year, and failed in the fourth year. So then we multiply each of these probabilities by the corresponding payment, and we know the expected value will be the summation of all these PXs. So that rounds to 2694 when you sum that. That's choice E.